You will know about grinding and related operations. In our previous 4 lectures, we already discussed in lecture 1 turning and related operations, in lecture 2 shaping and related operations, in lecture 3 drilling and related operations, and in the last lecture, that means lecture 4, we discussed about tapping and milling and their related operations. And this is lecture 5, and here we discuss about grinding and related operation. So let's start the video. Introduction. The grinding process consists of removing material from the workpiece by the use of a rotating wheel that has a surface composed to abrasive grains. Grinding is considered to be the most accurate of the existing machining processes. Grinding processes are used when high accuracies, close dimensional tolerances, and a fine surface finishes are required. Hard materials can also be machined by grinding process. This is a figure of schematic illustration of a horizontal spindle surface grinder. See here, this is a grinding machine. Wheel guard, work table, workpiece, saddle, feet, bed, column, wheel head, all are indicated in the figure. Two important components, abrasive grains and bonding materials, make up a grinding wheel. Often, additives are blended to create a wheel with the properties necessary to shape a particular material in the manner desired. Abrasive grains constitute the central component of any grinding wheel, and the hardness and friability of the grinding materials will significantly affect the behavior of a given wheel. Hardness is measured in terms of a relative scale developed in 1812 by a German mineralogist named Friedrich Mohs. On this scale, extremely soft talc and gypsum represent hardnesses of 1 and 2, and corundum and diamond represent hardness of 9 and 10. Friability refers to how easily a substance can be fractured or pulverized. People who design grinding wheels consider the friability of their abrasives, which can differ with the nature of the materials being ground, very carefully. For example, while diamond is the hardest known material, it is an undesirable steel abrasive because it undergoes a destructive chemical reaction during the cutting process. The same is true of silicon carbide. On the other hand, aluminum oxide cuts irons and steels better than diamond and silicon carbide, but it is less effective for cutting non-metallic substances. Common grinding wheels. A grinding wheel is made of abrasive grains held together by a bond. These grains cut like teeth when the wheel is revolved at high speed and is brought to bear against a workpiece. The properties of a wheel that determine how it acts are the kind and size of abrasive, how closely the grains are packed together, and amount of the bonding material. See here, there are two figures. In the second figure, there are abrasive grain, grinding wheel, bolt, binder, workpiece, cavity full of chips, partly filled, and cavity. All are indicated in the figure. Right, the structure of a grinding wheel showing the cutting action of abrasive grain. And in the left figure, the rag angle of a single grain can be 0 or positive, but usually is highly negative.